Hi all, welcome to this session. So in the previous session we discussed the introduction of this numerical techniques. We discussed what is the importance of this numerical techniques in solving mathematical problems, how it can be used to solve the complex non-linear equations, etc. So in this session we are going to learn one of the beautiful concept of this numerical techniques, which is a finite difference of a function. I told you numerical technique is widely used to solve difficult equation, non-linear equation. It is used in interpolation techniques. It is used to solve difficult. It is used to integrate some complex function, or it is used to differentiate some complex function. And these problems, we are solving these problems, which is based on a concept which is called finite difference of a function. Unless you know what is this finite difference, you can't use or you can't solve the interpolation formula. You can't solve how to integrate a complex function. So first thing, you need to understand what is the finite difference of a function, and it is widely used in many techniques. So that we can say it is one of the building blocks of this numerical technique. So this is the importance of finite difference of a function. So in this session we are going to learn what is this finite difference of a function and what are the different types of finite differences. Let's move to the topic. So we can discuss what is this finite difference of a function. So finite difference of a function is nothing but it is the difference between two functional values. Suppose you have a function y equal to f of x. So y equal to f of x be the function. And you can consider a set of table of values which is based on this function. Which means you can say what is the value of what is the value of yi when x equal to xi. Okay. So you can find out what is the value of yi when x equal to xi. It is nothing but f of yi equal to f of xi. So in this way you can construct a table of values. So for each x value you can find a y value. Suppose I am just constructing a table for each x value. For the first value I am just assuming it is x1. So for x1 you have y1. For x2 you have y2. For x3 you have y3. x4 you have y4, and so on. So here I just considered only 4 values, and these y values are called functional values. So finite difference is nothing but it is the difference between two functional values. So it is the difference between y2 minus y1, or we can say it is y3 minus y2, etc. So these are the difference of the functional values, and we call these difference of a functional values as the finite difference of a function. Basically there are 3 different types of differences. First one is called forward difference, second one is called backward difference, and third one is called central difference. We have to learn these differences under the heading finite difference of a function. So for forward difference there is an operator which is called forward difference operator. Similarly you can have backward difference operator and central difference operator. And the forward difference operator is denoted by the operator symbol delta. So this operator is widely used for forward difference operator, and the backward difference operator is denoted by the symbol del, and the central difference by this delta. So these are the operator symbol of forward difference operator, backward, and central. We will discuss what are these operators in detail in our coming session. Suppose you have the difference between two functions y2 and y1, and already we have discussed that this y2 minus y1 is called finite difference of a function. You can express this y2 minus y1 either using forward difference operator or backward difference operator or central difference operator. So in all these operators, the value of the difference is y2 minus y1, but how you are writing this y2 minus y1, which is different in all these difference operators, that we need to learn. How can you write y2 minus y1 in forward difference using forward difference operator? How can you write this y2 minus y1 using backward difference operator or by using central difference operator? That we are going to discuss. In all these cases, the value of the difference is y2 minus y1, but the way you write the difference varies. That we need to learn. How can you use this forward difference operator or backward or central difference operator? First, we can see how to express this difference of a function using forward difference operator. Okay, so first we can discuss the forward difference of a function. Suppose we have a table of values xi, yi. Suppose we have a function y equal to f of x and we have the table of values of x and y. So first x value, we are taking the first x value as x0. So x0 will be the first x value. So throughout the chapter, we are using this x0 as the first x value. In some cases, we are just changing, but in most cases, we are using x0 as the first x value, and corresponding to x0, we have y0. So this is the first point, x0, y0, and the next second point, x1, y1, and the third point, x2, y2, x3, y3, x4, y4, so on. So here you can see the first difference of the function is nothing but the difference between y1 and y0. So y1 minus y0 is the first difference of the function, y1 minus y0. Second functional value minus first functional value. You can express this functional difference or y1 minus y0 in terms of forward difference operator as by using the forward difference operator delta. So if you see this delta, you have to understand this is a forward difference operator. Then you have to write y0. So this y1 minus y0 can be expressed in forward difference operator as delta y0. You please understand the way I wrote this forward difference operator. So first I wrote the operator symbol, which is delta, then I wrote y0. So y1 minus y0 is the forward difference value of y0. So this is important. So y1 minus y0 is the forward difference value of y0. Why it is called forward difference? So if you wrote this delta y0, delta means forward. So you need to understand from delta that is the forward difference operator. So if you see y0, you have to subtract what? The next y value. So next y value of y0 is y1. y1 minus the previous, y1 minus the functional value. So here the functional value is y0. So y1 minus y0. So in this way you can express this forward difference operator. Hence the name forward. Forward means the next or after the functional value. So what is the functional value after y0? Minus y0. So if you write delta y1, what does it mean? So delta means forward. So that y1, what is the next functional value of y1? It is y2. y2 minus y1. So you can express this y2 minus y1 in terms of forward difference operator as delta y1. Hope you understand. So delta stands for forward difference operator. Then you have to understand, you need to understand how to write that forward difference. So if I am saying delta y4, you have to write y5 minus y4. Okay, y5 minus y4. So this is the finite difference of the function, and if you express this y5 minus y4 as delta y4, then it will call that one as the forward difference of the y value y4. Clear? So these are the first order forward differences. Similarly, you can build the second order forward difference. For example, delta square y2. Delta square y2. So if it is delta y2, you know what is the answer. If it is delta y2, the functional value which is after y2, which is y3 minus y2. Clear? So if it is delta square y2, you have to use that delta operator also. So delta square y2 is delta y3 minus delta y2. Hope you understand. So if it is a second degree operator, you just take the subtraction by using the first order. So if it is delta square y0, it is delta y1 minus what? Delta y0. Delta square y0 means delta y1 minus delta y0. Clear? So here you have to understand another thing. Suppose there are 5 values. Here you can see 5 values, x0, x1, x2, x3, x4. And you have 5 y values also. If I am asking you what is delta y3, you have the answer. It is y4 minus y3, right? y4 minus y3. If I am asking you what is delta y4, do you have any functional value which is after y4? No. Here the last value is y4. So that you can't build this delta y4. Suppose if you have xn values or if you have yn values, if you have total number of n values, you can't find what is delta yn. Delta yn is invalid. You can't find out the value of delta yn. You can find the value up to delta yn minus 1. You can find the value up to delta yn minus 1. Here you can find the value up to delta y3 and no way to find delta y4. So here this is very important, and this is called forward difference of a function. We learn how to write the first order forward difference. We learn how to write the second order forward difference. Similarly, you can say what is the third order forward difference. If it is delta cube y2, it is delta square y3 minus delta square y2. Now you have to find out what is delta square y3. How will you find out delta square y3? Delta square y3 is nothing but what? Delta y4 minus delta y3. Okay, minus, and delta square y2, it is delta y3 minus delta y2. In this way, we can find out delta cube y2. So now we can find out what is the last y value of delta square y0. You please write delta square y0 as delta y1 minus delta y0. Now substitute what is delta y1 and now substitute delta y0 and find out what is the final answer. Hope you wrote what is the value of delta square y0. So what is delta square y0? It is delta y1 minus delta y0. What is delta y1? Delta y1 is y2 minus y1 minus of y1 minus y0, minus of y1 minus y0. So it is, the answer is y2 minus 2y1 plus y0. Hope you got the same answer, y2 minus 2y1 plus y0. So this is delta y0, y2 minus 2y1 plus y0. The question is, what is delta square y1? What is delta square y1? How will you write? So it is delta y2 minus delta y1. What is delta y2? y3 minus y2 minus of, what is delta y1? y2 minus y1. So the answer is y3 minus 2y2 plus y1. So this is the value of delta square y1. So I am just giving some problems as homework. You have to find out what is delta raised to 5 y3, then delta cube y2, etc. So these are the two problems. Find what is delta raised to 5 y3 and delta cube y2. Just do these problems as your homework. Okay. So this is all about forward difference of a function. So we learned the first order forward difference, second order forward difference, third order, and we can write the nth order forward difference also. So based on these, we can construct a table which is called forward difference table. Based on these difference values, we can construct a table which is called forward difference table. Next, we will learn how to frame that forward difference table. So we can learn how to write this forward difference table. Suppose we have the table of values. For x0 is the first x value and y0 is the first y value. So we have x0, y0, we have x1, y1, we have x2, y2, and we have x3, y3. So we learn the first forward difference as delta. So delta means the first forward difference of the function, first order forward difference of the function, delta. We learned delta y0 as it is y1 minus y0. So the difference between y1 and y0, which is y1 minus y0, can be expressed in the forward difference operator. We can express this y1 minus y0 by using the forward difference operator as delta y0. So in this place, here you have to write what is the difference between y1 and y0. What is the difference between y1 and y0? It is delta y0. It is delta y0. So if the question you have some values here, so just subtract these two function values, and in the middle of these two function values write the value of that delta y0. So next, in this value y2 minus y1, here you have to write it is delta y1. Hope you understand. In this way we can construct the forward difference table. So here you have to write delta y2. So if you have some other values x4, y4, here you have to write delta y3. But here we can write only up to delta y2. No way to write delta y3 because no y4 value there. So these are the first order differences. Similarly, you can construct second order differences, delta square. And we know the difference between delta y1 and delta y0 as delta square y0. Delta square y0. And the difference between delta y2 and delta y1 as delta square y1. Delta square y1. Similarly, you can construct the third order difference, delta cube. So y cube, the first member of this third order difference is delta cube y2. Delta cube y2. So from the table it is very clear that delta cube y2 is the difference between delta square y1 and delta square y0. So in this way you can construct the forward difference table. Okay. Here you need to understand another thing. So these are the position values. So delta y0 is the first member of the first order difference. Delta y1 is the second member of the first order difference, and delta y2 is the third member of the first order difference, and delta square y0 is the first member of second order, And also delta cube y0 is the first member of third order. So all higher order differences starts with y0. The second order difference starts with y0, third order difference starts with y0, and also what? The fourth order difference also it will be started with y0. So this is an important point. All higher order differences in forward difference operator starts with y0. Clear? And you do a work by yourself. Suppose you have some x and y values. Suppose you have some x and y values. Suppose you have for x equal to 1 you have y equal to 3, and suppose x equal to 2 you have y equal to 6. For x equal to 3 y equal to 9. For x equal to 4 y equal to 11. Just construct a forward difference table for this table of values. You need to construct a forward difference table based on these x and y values. So in this way you can construct a forward difference table. Hope you understand what is the forward difference of a function, how to write the forward difference of various orders, and how to construct the forward difference table. If you have any queries, you please comment. We can clear those queries. And I hope you understand all these things. Thank you.